All right, then. So in this video, we're going to discuss about the concept called polymorphism. So before jumping into the video, I'm going to clean up all these codes and let me open the multi-line comment, enter, and we are going to discuss about the concept called polymorphism. All right. So the polymorphism in the context of object-oriented programming language, that's object-oriented programming, refers to the ability of a class to take on multiple forms. This concept allows the object of different classes to be treated as an object of a common base class. There are two main types of polymorphism, which is compile time and runtime. So let's talk about much briefer in a briefly way. So poly means the term poly, that means many, and morphism means shapes or forms, which is typically we can say it as many forms or many shapes, right? So it refers to the concept of like the ability of a class to take a multiple form. It's ability of a class to take on multiple. Okay, so let's see. So it's having two different types. One is the compile time and another one is the run time. So both of these are achieved by a very specific methodology. This can be achieved by function overloading, and this can be achieved by you can say dynamic let's say dynamic binding, or we can simply say like a virtual function, right? So let me explain one after another with the different examples. So first let's talk about the compile time, which is the function overloading. So let's see how the function overloading will work, also known as the function the compile time polymorphism. It can be achieved by using function overloading, and a compile time polymorphism is also known as the compile time polymorphism is also known as the static polymorphism. Static polymorphism, or we can say it as an early binding. Early binding. So this occurs when multiple functions with the exact same name but different parameter list exist in a class. So this happens when the function overloading happens. It occurs when multiple functions with the same name but different parameter lists exists in a class. All right, so the correct function is determined at the compile time based on the function call. So when the correct function is being determined, the correct function will be determined at compile time based on the function call, right? So let's have an example. So let's have an example to understand this. So here hash include IO stream, hash include, come on, IO stream, then class print info. Just we are going to create a function to print the information. So I'm going to keep it as a public, and here void display, that's the function I'm going to create, and it's going to display an integer value. So see out displaying integer colon, then I'm going to display the value, then I'm going to end the line, right? So then okay, forgot to using namespace std, right? So after, so here it's expecting a semicolon, fine. So I'm going to have one more function which exactly going to be the same, but this time it's going to be a double value, which is quite different. This is a different data type and this is a different type, but the function names are both are same, right? So let's see. All right then. So now let's jump into the main function int. Okay, so before moving into that, I need to change this to displaying double, right? So int main, open it and return 0 here. So I'm gonna create an object for this printer semicolon. So printer dot display. So if I'm supplying the value as 5, so the same function it's going to call this based on the parameter value whatever I'm supplying, the function will react to it. 5.8 or something. Now it's a double value, it's a float decimal value, right? So let's check it out. If I run this, you see here the same function, right? We call the same function and it's working. So this is called the function overloading. A function will have a same name. You can have n number of functions in it, but there should be any one difference. Either their parameter or their return data type should be different. That's the function overloading. So now let's jump into the runtime polymorphism, which is the virtual function. So runtime polymorphism, right? So runtime polymorphism, it's also known as the dynamic polymorphism, right? Or you can say late binding, right? We can say that the functional overloading is going to be static binding and this is going to be the late binding. All right, then so this is achieved through the use of virtual function, which is achieved through the use of virtual functions and the pointers references, and with the help of the pointers references, right? So the correct function is determined at the runtime, as a runtime based on the actual type of the object. So correct function is determined at runtime. All right, runtime based on the actual type of the object, right? So this is all about the runtime polymorphisms and the virtual functions, right? Let's see how exactly we can achieve this by using a simple example. So let's keep it as print info over there. So here I'm going to create one more function called class shape. Open it, and here I'm going to create that virtual function inside this public thing. Let me open it and let me bring this. Oops. So here let's bring that public colon. All right, so now here I'm gonna bring void draw. This is the function that we are going to create, and this is the function which we need to make it as a virtual function. So what we need to do is to create it as a virtual function, we need to keep it as we need to keep a virtual keyword. All right, so right after this public, so I'm going to use the virtual keyword over here, virtual void draw. That's the function I'm going to create. So here I'm going to say it as cout, like drawing a generic shape. Let's say drawing a generic shape or something, and let's end this line semicolon, right? So this is that function, a virtual function which we created. And now over here I'm going to create class circle colon, and I'm going to extend that shape over here. I'm going to inherit the properties which is coming from the shape. Okay, and inside here I'm going to keep it as a public, And here I'm going to use the draw function, and I'm going to override this function. So override, using the keyword override, and I'm going to override this function instead of simply displaying this as a generic function, and I'm going to say this as a drawing a circle shape. Copy this, drawing a circle shape. Just like the same way, I'm going to call this one more time, and I'm going to paste it, and I'm going to say square, and I'm going to override this as a drawing a square shape, right? So if you are calling this function, what is this? Okay, we are getting an error expecting semicolon at the end of the each classes, semicolon. All right. So this is the shape, right? And it's having a virtual function called draw. So basically we don't have the draw function which is inside the circle. We are using the draw function which is coming from the shape, and we are overriding its default behavior just by using the override keyword, and we are changing everything over here, right? So inside this main function, now what I'm going to do is right after here, and I'm going to create an option for shape, and it's going to be a pointer. Okay, so let's use the shape ptr, just like the way this is how you need to create a reference for that particular class, right? Then I'm going to create circle car semicolon and square sqr semicolon. All right, so now we have those different objects for each and every classes. Now I need to supply the address of that particular class, the address of this class to this object. So shape ptr which equals to ampersand of circle, right? Semicolon, ampersand of the circle object cr. Then using the shape pointer object, shape pointer, and I'm going to call the very specific function which is inside that circle object, the circle address. So I'm going to call that draw method which is inside that circle method, semicolon. So just like the same way, I'm going to send the address reference of the square object to the shape pointer. So shape pointer equals to address of the square, semicolon, and then I'm going to call using the reference pointer reference, and I'm going to call the draw method which is in that address, in that specific address. This is how you can use the overriding method over here. Let's save these changes. So far there is no syntactical mistakes over here. Let's check it out. Is there any runtime error or not? No. Look at that. We are getting the messages drawing a circle shape and drawing a square shape. So basically we are overriding this virtual method as per our wish of our customized class, and we are calling that object according to the pointer reference whatever we assigned to that specific pointer over here, right? Basically we are creating an object and we are assigning that object as a reference to this shape class, and from that specific object we are calling the draw method, and according to that specific address it's calling that specific draw method which comes from that shape class over here, right? So this is how you need to override a function which is happen only through the virtual function, right? I hope you guys are so excited about this section, because this is the most important thing when it comes to real-time project building, right? I hope you understand this section, right? So let's move on to the next interesting concept.